Assalamu alaikum wa rahmatullahi wa barakatuh. Good morning, everyone. Today, inshallah, we will go through, we will continue our revision in the previous two sessions. We already did go through integration and also through different integration application areas. We did go through numerical integration and complex in the previous lecture. Today, inshallah, I will continue on systems of equation, our solution of a system of equations. But before going through it, I would like to go through the exam brief. What's going to be covered in the latest classwork, second classwork, inshallah, and it will be 10% from the total grade. First of all, this module should satisfy the understanding of the different integration main rules, evaluation of integration by parts, knowledge of integration by substitution, knowing and understanding the application of definite integration. Take care, you will have to review the mean value theorem and, of course, the area. Knowing about numerical integration, we already did go through trapezoidal rule and Simpson rules. Knowing about complex number and the polar form, and the Euler forms, and how to migrate, simplify complex numbers into the complex step. Understanding about algebra, matrices, solution of a system of equations. Of course, you will have right to have one quarter paper, double-sided, okay, containing many main laws or formulas, only with you to the exam. Various exam instructions, read your questions carefully, make sure your work is for credit, make sure your mobile phone.
A quarter paper.
What?
In a quarter paper. Let's say
A quarter, A4. And if you use A3, some people using A3, it's not allowed, okay? Make sure your mobile phone is switched off and place it in your bag, okay? Then, let's start solving these methods using grammar method, which is very, very simple. All I have to do first to handle these types of systems, first of all, you will have to put them in matrix form as we talked previously. First of all, you will have to be sure that they are already arranged. You have the variables in one side, while the numbers on the other side for this system. I will finish this and we'll start the other one. Then start putting them in a matrix form. First of all, already arranged, so check is okay. Then it's gonna be 1, then 5, then -7, +2, and then you will have the unknown matrix, which is x, y, and this is going to equal to the result matrix, which is -11, -18, as you can see. In order to solve using grammar, all we have to do is to read the values like this. x1 will equal to delta of x, the determinant of the x unknown, divided by the determinant of the coefficient matrix, and it should be written in this way. I would like to see it in that way, please. 1, 5, -7, 2, same way like on the upper, in the denominator, just only with one slight difference. You will have you will have -11, then -18, and it's going to equal to. In a similar manner, for this is for the variable x, for the variable y, it's going to equal to delta stand for y, and the coefficient matrix delta. So in a similar manner, same denominator, 1, 5, -7, and 2. Please, in all times, try to recheck the numbers. Sometimes, if you don't write them with enough spaces, you may mix the sign or something. So please be sure about that. The next step, you will have 1, 5, then let's do that, -11, then -18, which is gonna net 2. First of all, I will try to evaluate the denominators. So multiplying the principal diagonal values minus the secondary diagonal. So it's gonna be 2, then plus 7 times 5, which is 35. I believe it's gonna come up to 37. This is 2 plus 35. For the denominator, it's going to be -22, -7 times 18. Please use your calculator. Same way, or the calculator will sit. 1 times 2 plus, so you will have 37. In a similar manner, you will have negative 18, then plus 11 times 5, which will end up to equal. This is how we go through Cramer's method. Okay. In a similar manner, the other problem, you can simply do the same exactly in a similar manner. Did you evaluate the upper determinant? Negative 22 minus 7 times 18. Negative 4 overall. Okay, so this one is negative 4, yes? Okay, so it's going to come up to negative 4, this is x negative 4. And for the other, y will equal to 1? I believe 1. Yes, exactly. In a similar manner, and exactly in the same way, you can also solve the other problem. I will leave it for you for training. Or we can solve it already. We can solve it really, really fast. Same way, like, first of all, try to plot this on a matrix form in a similar manner. It's really a very simple question. Okay. So this is going to be 7, negative 4, negative 8, then 2. Okay, then you will have x and y, this is negative 12, and this is positive 3. Second step, I will get the value of x, which is simply can be easily evaluated as 7 minus 4, negative 8, positive 2, and this is the denominator, while the denominator is going to be same way like, so it's going to be negative 12, 3, negative 8, and 2, start evaluating the value. Same way like for y is going to equal 2. In a similar manner, the denominator will be the same, which is 7, 2, minus 8, minus 4. And for the denominator, for the denominator, you will have 7 and negative 4, while the other column is going to be changed to be negative 12 and 3, and so on. You can evaluate both the values of x and y. It's really very simple method, and it's really very successful once you are dealing with the system, 2 equations and 2 unknowns. It's really very nice. This is nice. Any questions? Okay, it's really very simple. I will send you this PDF if you like to resolve it. Okay, let's see the other problem. Here, I need to solve this system, but not using Cramer method. We will use the inverse method. The inverse method, first of all, the first step is to put this system of equations into a matrix form. Even first step, I will try to put it in a matrix form. لو حبيت احط السيستم ده on a matrix form, it's going to be like this: 1, 5, negative 7, 2, and still you will have x and y, and this is going to equal to negative 11, negative 18. The idea behind the inverse method, as you know, simply we put these matrices on this form: A times x, which equal to B. So simply, if we multiply both sides in A minus 1, if we multiply both sides in A negative 1, the inverse of the coefficient matrix, simply it's going to lead to A minus 1 times AX, which equal to A minus 1 times B. That's x will equal to A minus 1 times B. This is how we can solve this system using the inverse method. All you have to do is to get the inverse of the coefficient matrix, then multiply by the result. You will get the values of the unknowns. Let's start doing that. First step, in order to get the inverse, the first step is to get the determinant of A, or the determinant of the coefficient matrix, which is simply the determinant of 1, 5, negative 7, and 2. And this is going to come up to 37. Let's do it. So it's gonna come up to 2 plus 35, which is gonna be 36. This is the first step. Second step, do you remember how to get the conjugate adjoint matrix? Anyone? So this is second step. A11, A12, if you remember. This is A21, this is A22. Start putting the signs positive, negative, positive, negative. Once more, positive, negative, positive, negative. Those are the signs. Then start eliminating the element 1, 1. Eliminating the element 1, 1, you will have 2. So this element is 2. Eliminating the element 1, 2, raising the first row and the second column, you will have 5. Then eliminating the second row and the first column, so you will have negative 7 times negative, which is going to be positive 7. In a similar manner, raising the second row and the second column, you will end up having 1. Now we can simply get a minus 1. A minus 1 will equal to 1 over the determinant, 1 over 37. Then open the A matrix, which is the adjoint matrix, which is simply 2, then negative 5, then you will have 7 and 1. That's A minus 1 is going to be 2 over 37, 7 over 37, negative 5 over 37, and 1 over 37. انت كده جبت A minus 1, or you already have the inverse matrix. In order to continue, I will start using this form. That's X, which is the unknown matrix, which is simply X and Y, will equal to the inverse matrix, which is 2 over 37, 7 over 37. In a similar manner, negative 5 over 37, then 1 over 37, and all of this is multiplied by the result matrix, which is negative 11, then negative 18. دلوقتي أقدر أحسب الفاليو of X. That's in X and Y. Once you start multiplying, you will have, this is 2 by 2, and this is 2 by 1. So the new matrix is going to be 2 by 1. Start multiplying the first row by the second column, which is going to develop. Okay, I will write it. Just let me write it in order to be in front of you. So it's going to be negative 22 over 37, then 7 over 37 minus 18, so you will have minus 18 times 7. I believe it's going to come up to negative 4. And then multiplying the second row by the column, multiplying negative 5 over 37 times negative 11, which is going to come up to positive 55, then minus 18, which is going to come up to 1. That's in X and Y. It's going to be negative 4 and 1. This is the main method of using the inverse matrix in order to get a solution for a linear system of equation. Why using Cramer method? It's really very simple for a 2 by 2 system, but once you go to 3 by 3, it will start to be a little difficult, as you will see in the coming example. But for the inverse matrix or for the inverse method, it's supposed to be simpler in the case of a 3 by 3 matrices. Okay, any questions? It's really very simple, okay? خليني نبص على اللي بعديها برضه انا ممكن ارسل لك البي دي اف تبص عليه بعد كده. هنا بيقول لك use the two methods, the inverse method and the Cramer method. انا هعمل ده او هنعمل المساله دي بحيث ان انت تبقى خلاص انت كل حاجه قدامك مظبوطه، الجزء ده مفترض ما فيهوش مشاكل. On next lecture I will talk about Gauss-Jordan chart. First of all, exactly in a similar manner. First of all, I will try to put this system into a matrix form. But first of all, just to check they are already arranged X under each other, the second column which is Y columns, the third unknown which stays third column, then start putting them into a matrix form. لما ابدا احط ده in a matrix form, you will have it this way. This is x, y, and z, and it's gonna equal to negative 15, then negative 21, then positive 18. The values will be 1, then 2, negative 2. For the second row, 2, 1, then negative 5. For the third row, it is 1, minus 4, and 1. It's exactly the similar way. Second step, if we need to solve this using Cramer method, all we have to do, أعمل ده using Cramer method. أعمل إيه? First of all, I will get x, which is going to equal to. I will put the determinant of the coefficient matrix. Let's take the rule first, then we substitute. I will get delta x divided by delta. Then we will go for y, which is simply delta y over delta. Then we will get the z value, which is going to come up to delta, then delta z. Let's start with delta x. So all you have is 1, 2, and 1, 2, 1, negative 4, and then you will have negative 2, negative 5, and then 1. This is for the denominator determinant. In a similar manner for the denominator, it will be exactly the same. 2, and this is 1, negative 4, and this is going to be negative 2, negative 5, and 1. And for the first column, we will replace it with negative 15, negative 21, then 18. Negative 21, and that's 18. That's for delta x. In a similar manner, I can get the values of y. Y is going to equal to delta of y over delta, which is going to come up to. حد يقدر يحكي لي الديترمنت ده؟ حد يقدر يجيب الديترمنت بسرعه؟ فاكرين؟ شباب كنت بحسب الديترمنت ده ازاي؟ Do you remember؟ كنت بقول بمسك عناصر principal elements of the principal element 1 times 1 times 1, which is simply gonna come up to 1. Then plus 2 times negative 5, which is negative 10 times 1. So it's gonna come up to negative 10. Then in a similar manner, negative 4 times 2, which is negative 8. Negative 8 times negative 2, which is going to be positive 16. Then minus all the bracket. In exactly a similar manner, I will get the multiplication of the secondary row, which is going to come up to negative 2. Then negative 5 times negative 4, which is 20. So it's plus 20 minus, plus 2 times 2 times 1, which is plus 4. بالتالي اقدر احسب الريزلت بالتالي احسب على كده. اللي فوق هيبقى same way like, which is you can re-evaluate it in a similar manner. So assuming this is okay, so you can get x very simple. In a similar manner for the unknown y, we will have to, the denominator will stay the same. So it is 1, 2, and 1. 2, 1, negative 4. This is going to be negative 2, negative 5, and positive 1. For the upper determinants, it's going to be 1, 2, and 1. Then once more, you will have negative 15, then negative 21, then positive 18. For the third column, as you know, negative 2, then negative 5, then positive 1, and so on. You will get the result of the denominator, and you will get the unknown. جبته؟ كام؟
negative 15.
يبقى إذا هتلاقي عندك ده النيجاتيف اللي فوق على negative 15. In a similar manner, for the last unknown, it's going to be negative 15, which is the value of the coefficient determinant. Then in a similar manner, exactly the same, we will try to put 1, 2, 1.
then 2, 1, negative 4, and then we have negative 15, negative 21, then 18. In a similar manner, you have the denominator is negative 15, and you can get the value of x, y, z. This is the method using hammer. As you can see, it's very, very simple, handable. The only problem is you are dealing with a 3 by 3 determinant. If you do it by Sartre-Schumann, it's going to be very, very, very simple, other than using the cofactor method. So you will end up having a lot of 2 by 2 determinants. You don't need to do this, okay? Okay, if we want to resolve this problem using the inverse method, so it's going to be really almost the same like the previous one. Let me clear this area and let's start getting the inverse and do the same. Okay? Yeah, some are you about? I'm خلص كل حاجة. Okay. And how now we are going to try to solve this system using the inverse method. Exactly like the other problem that we solved previously. So instead of dealing with this system on this form, I will replace it to be a times x, which equal to b. That's x will equal to a minus 1 times b. So simply all you need to do is to get the inverse of the coefficient matrix. In order to get the inverse of A, the first step is to evaluate the determinant of A. So delta is going to equal to, once more, you will have to write the determinant of the coefficient matrix, which is 2, 1, negative 4, then negative 2, negative 5, and then 1. I will take your word for it. It's going to be positive 1. Then you will have negative 6, so it's going to come to negative 9. Negative 9, then you will have, okay, so it's going to be negative 16, negative 9 plus 2, it's going to be negative 25. On the other side, you will have negative 2, then you will have negative 20, then plus 4, so you will end up having negative 15, so, okay, so this is going to be negative 15, and it doesn't equal to 0, that's A is a singular matrix. So really this system has a unique solution. Second step is to try to get the adjoint matrix. So I will start with the cofactors A11, then A12, then A13 also. Of course you remark that we are writing a row element, but in a column we did two things, two steps actually together. We are evaluating the cofactors, and we already make transpose for these values. For A to 1, for A to 2, for A to 3, then we will have the other numbers, which is A31, A32, then A33 equal. I will start, of course, putting the sign rule, which will start like this: positive, negative, positive, then negative, positive, then negative, then positive, negative, and positive. Then, in a similar manner, I will start going through the coefficient matrix, eliminating the first row and the first column, which is going to come up to 1, then negative 5, negative 4, then 1. For A12, same way like for A, first row, second column, you will have 2, then 1, by then negative 5, positive 1,
For 1, 3, for the first row, third column, you will have 2, then 1, minus 4, so it will come up to these values. I will write them in another color. So you will have this is going to be 1, then minus 20, so I believe it's going to be negative 19. Please check with me. So, yes, then 2 plus 5, which is going to be 7, so this is going to come up to negative 7. Then 2 times negative 4, which is simply negative 8, minus 1, so it will come up to negative 9. In a similar manner, for A to 1, I will get erasing the second row. You will erase the second row and the first column. You will have 2, negative 4, and 1. Okay, here we go. So it's going to be 2, then negative 4, then negative 2, then 1. For 2 by 2, you will read the second row and the second column. You will have 1, then negative 2, then 1 and 1 and 1. For A, 2, 3, in a similar manner. So 1, 2, 1 minus 1, 2, 1, and negative 4. صح؟ في حاجة غلط؟ الأولاني هيبقى نيجاتيف 7. زرقاء. أي منطقة؟ أنت بتحسب القيمة يعني؟
تأكيد عليك؟
A to 1, 2 minus 2, بعدين negative 4 plus 1. يبقى لا, it's going to be 2, then minus 8, so it's going to be negative 6 times negative, so it's going to be positive 6 for this one. This is going to be 1, then plus 2, so it will come up to positive 3. The other one, 1 times negative 4, which is negative 4, minus 2, negative 6 times negative, so you will end up having 6.
لكن negative 7
and negative 7.
A12 يعني.
اوكي ماشي مش فاهم بقى. A12 first row 2 1 negative 5 and 1. 2 times 1 which is 2, then plus 5 which is going to be 7 negative 3. In a similar manner for A31, same way like A3 and 1, and in the third row, first column, so you will end up having 2 and 1, then negative 2, negative 5, this is for the first determinant, but for the second, you will erase the third row, second column, which is going to come up to 1, 2, so you will come up to 1, 2, then negative 2 and negative 5, negative 2 and negative 5, okay? For the third row, third column, it's going to come up to 1, 2, 1, 2, 2, 1. So the value is simply 2 times negative 5, it's going to be negative 10 and 7. It's going to be negative 10 plus 2, which will come up to negative, negative 8, I think. Negative 10 plus 2, so it's going to be negative 8. On a similar manner, you will have negative 5, then plus 4, so you will end up having negative 1 times negative, so it's going to be positive 1. For this one, it's going to be 1 minus 4, so you will end up having negative 3. Now, simply, we can get the values of the unknowns, which is x, y, z, which is going to come up to the inverse matrix, which is simply negative 19, then negative 7, then negative 9. For the second column, it's going to be 6, then 3, then you really will have 6. For the last one, it's going to be negative 8. Let's get some space. Okay? It's going to be negative 8, then you will have positive 1, then you will have negative 3. This inverse matrix will be multiplied by the result, which is negative 15, negative 21, and 18. I really made a mistake. Anyone? What's the mistake? What did I forget to write? I forgot to divide the cofactors
on the determinant of the matrix. Okay? So actually, it's remaining just to times, I will write it here. So it's going to be divided by -15. This one too, it's -15, similarly like -15. And in a similar manner, -15, -15, -15. Okay, -15, and similarly like -15 times -15. Start multiplying, and then you will get the values of your unknowns, which is simply x, y, and z. Remember, we already multiply the row by the column. So the first element is going to be 19 over 15 times 15, which is 19. Then 6 over -15 times -21. Then plus positive 8 over 15 times 18. And then you will get the value of x, similarly like y, similarly like z. This is how to handle a 3x3 system using either the inverse method or the grammar method. Please write it in details as I show you. I need to see the steps that you are already successfully getting the inverse matrix, got the determinant, it's not equal to 0, and proceed with the summary steps. Any questions? Okay? Okay, very good. Okay, so this is for you, just solve it. Next time, inshallah, I will go through Gauss-Jordan, inshallah, and we will go through the terms of Gauss-Jordans and the details of this system. Thank you very much. I will see you next time, inshallah.